All right, so video died, but we're coming back at it. Help me out here. How do we get on part 1, sketch vectors in component form? We need them in component form first. How do you find component form of a vector, like if we're doing U? So Redmond says x2 minus x1. What's negative 3 minus 4? Negative 7. And what's 2 minus 4? Negative 2. Okay, I see some groups in here getting the right thing or the wrong thing. So little mistakes happen. I can't tell that group. Looks like they did it. Even if you made a little mistake, we'll just clean it up now. Like, no big deal, right? What is V as a vector in component form? So 6 minus 1, 5, and 7 minus 1 is 6. Have I lost anybody how I got these? I just didn't show the steps in it. Okay, now if we were to sketch these, and I want you to sketch this, there's not many times where I show you guys multiple ways. The book shows you 2 different ways to interpret this. We do the exact same math. I just have 2 ways to think about it. So if we graph these, and I'm going to go, thankfully I have graph paper. Can we just assume that this is my origin, and I'm not going to like really truly expand stuff out? Like that's the origin of an XY scale. Okay, vector U starts where? Yep, so we're graphing it in which form? So if it's in component form, where's its initial point been moved to? The origin. What's this point? So you're right, but what is this? The origin is here, and then that's what? X and Y and where it ends, right? The final point. So I'm just going to go down to negative 7, negative 2. That's where it ends. This, to me, looks like vector U. Do you guys agree with that? Now, vector V, very similar. Because component form is nice and we've made it nice, where's its initial point? As long as it's in component form. The origin. Now, if you are looking at that going, what do you mean it's at the origin? I'm just going to show you something. This goes to 6, 7, right? So let's see. It goes, let's see, 6 and 7's all the way up here. Is that vector V right now not in standard form? Like it's just kind of floating out wherever. But hold up, I'm going to move it because I just want you to notice something. When I pick this whole thing up and I move it to the origin, where does it end? Which is exactly where we said it should end. So I just drew the original and then I moved it, which is what the component form is doing. Okay, are we okay here? Now, for 2, to add this graphically, one group, and in fact it was these ladies right here, already have it on the right track. There are 2 methods, and I'm going to go through both of them. I'll show you the one that I prefer, but I'll make sure you can see both of them. The da statement. 100%, you will remember that moving forward. If I look at either of these vectors, we agree that they all have a forward end and a backward end. Like there's a tip of the vector and there's a tail of the vector. Okay, tip to tail is what we're going to physically write down. Which tip to tail. Ba, ba, ba. That's what I was hoping. We might not have gone this far into it in geometry. I just don't recall. Tip to tail. That is the most important thing. So check this out. If I want to add these vectors, first and foremost, it doesn't matter which one goes first with this, and we'll sort out those properties. I'm simply going to make a copy of vector U right here. And I know it's going to have like another spot. If I wanted to do V plus U, and I'm going tip to tail, where's the tip of V, do you think? And I'm just like, am I at the tip or the tail right now? So, tail, the back end of it. Where's the tip of V? I start working all the way up to here, right? Now, if I just imagine this, and I'm going to go ahead and do those 2 solid. I've added vectors right now. And it's almost like this one has disappeared, and I'm not going to erase it. Is there a single vector, which is what we should expect, that will take me from where I started to where I ended? There's a single vector that will do it. This vector right here, and we're going to define all this nicely, is what we call our resultant. This is where we actually get the answer. Now, I do want to highlight that I looked at something up here that these guys were really close. You've started to try to put them together to make these other shapes, right? Now, you've made a triangle. If I had instead done U plus V instead of V plus U, and I just added V on here, this is where vector V would be. So whether we want to think of a parallelogram like this, or we just do tip to tail, they'll both work out for us. In either situation, could we find the length of this blue line? How? Or not just the length, can you tell me where it ends? If we trust the picture, because I'm drawing stuff pretty nice. Negative 2, 4. So I'm just going to make a claim, weird. My resultant, and I'm going to make this one in green so it stays. The resultant vector is what we call our new vector. Resultant vector. And I'm going to call that R here, just so it's the resultant. Seemingly, you guys just said was equal to negative 2, 4. And I'm only basing this off of the drawing. And again, it doesn't matter whether I do v plus u or u plus v, because they both wind up right at this point. Just to remind you of that. Nope, can't do it now. Okay. What if we tried this analytically? Like, and when I say that, analytically, what does that mean even, when you guys see that word? Does it mean anything to you, or do you just think it's going to be hard? Just numbers, like no graph, right? Analytically or algebraically, let's just see if we can figure out how this worked. Before we move on past this, and we'll do another one, so like don't stress about it. Last questions about how I got this R vector. Yeah. Can I do it the other way? Like, and I'm just going to, instead of, I just did u plus v or v plus u to get it. And I just want to convince you that we can get to the same spot. If I have both of these vectors right here, let me undo that last one. And let's pretend I didn't do this one. Could I make a copy of this red one and add it tip to tail on the black one? So I just want to see where that happens. And that's it, right? Like that does it. Where does it end up? Like if I, and by say where does it end up, I mean we started at the origin initially, and then at the very end, if I just go to where we ended, it ends right there, right? And what's that ordered pair? 1, 2. So it looks like negative 2. 1, 2, 3, 4. 4. Did we just get the exact same answer even though I changed the problem? And it all happens because we do it how? Tip to tail every time. Now, turns out that it just is the diagonal of this lovely parallelogram that we get if we do all 4 pieces. I like to just do tip to tail and look at it and make sense of it, but you could do the big parallelogram and make it work if you want it. Now, I just want to see, could we do it without it, meaning analytically? So I'm going to kill my graph, or at least come down here, and you guys, I just want to look. We just found that u plus v should be this. Well, let's just see what happens, and let's just try it. If I didn't tell you to graph it, but I'd gotten it in component form, and I asked you to evaluate u plus v, does anybody have a thought of something to try, whether you think it'll work or not? So let's write it out first. But Red, I think I agree with you. What was u as a vector? So like this one, it's negative 7, comma, negative 2. And I'm just taking the fact that we knew u, and I'm changing it. I can't tell if this is really hard or really boring or both. Like, it's not just you, just so you know. Like, I'm getting a lot of glassy eyes. Feels okay. What's v? 5, 6. Now, Red said it right off the bat, but I want you to quietly, we'll go like 15 seconds, with your neighbors. If you got to write the rules on how this worked, how would you want these to add up? 15 seconds, I'm going to call on somebody random. Talk it out. How would you want this to work? Christina, do you have a good idea? Do you have an idea? So absolute value, what do you mean? Okay, so because we have to have the direction, I like that's where the negatives come in, but I like that idea. I like that you're trying to avoid the negatives, but we have to with direction. Now, let's just think about what a vector actually tells us. It says walk this far in the x direction, and then walk this far in the y direction, if we get it in this form. If we think about what's going on with this red and the black one, the red one says walk 5 to the right. Do you guys agree with that? The black one says walk how many to the left? And if we did 5 to the right and 7 to the left, how many in which direction would we wind up going? 2 to the left. What did we wind up? Oh. Okay, so Red, you suggested it right from the get-go, and I was hoping somebody else would suggest it too. Anybody have a way that we can maybe make this work? Red has it. I know he does, and I'm confident somebody else has it. Dolan, what do you think? Wouldn't it be really awesome if all we had to do was just add the pieces? Like x to x makes sense, I think. And then what should we have on the other spot then? -2 plus. And then let's just check something real quick. If we actually do this, we just go x to x and y to y, like seemingly would be the nice way. What do we get for the x's in the end for our resultant r? -2. And what about in the y direction? When we drew it, what did we get? Oh, would you rather draw it or do it analytically? It is so much nicer. But it really does make sense. There's a reason we use this in physics. If I'm going at some angle and I need to know, well, how fast will I go in the end? And we'll do some physics problems with this, I assure you. So scratch that. Aisha's psyched about it, I can tell. Did we talk about pips last week?
Yes.
Did we do it?
No.
Okay. Let's go one more little spot here. And we'll come back to it, I assure you. Okay. We are close to being able to take a brain break. Let's get a couple things. We're going to, I lied, we're going to take a brain break first, but I'm going to write the title. So, we're still in the same section. And I started midway down, I don't know why. Okay, what we just did is instead of me saying, here's a new idea, let's do some examples with it, I gave you the example first so I could see how much we needed to talk about it, which that's fine. But let's talk about operations with vectors. Now, there's only 3 of them that we need for today. And most of them are pretty nice, just so you know. And there's actually a whole lot of properties that we'll look at. I don't think we're going to write them all. But let's check this out. If we have the following, and we're just going to get both of them. So let's go ahead and let U be a vector that we'll say is in component form, and we'll just call it U1, comma, U2. And you could use X1, Y1. I'm just going to use U for vector U. And then we're going to get a vector V as well, where it is in component form. We'll say its X coordinate is V1 and its Y coordinate is V2. Now, the most important thing is that these are already in component form. They've been made to that angle bracket is the real name for those, just in case you guys wanted to know. I'm going to keep calling them insta brackets, but cool. We just wrote a rule for at least one of these. We have addition, and I'm just going to define it really quick and easy here. We have addition. And there's one more little spot that I'm going to have to click on here. We're also going to give ourselves K and just say that it's an real number. So we have some number K floating around that hasn't been mentioned yet. Okay, for addition, and I cannot stress this enough, which form are we in right now? Component form. So like this is not always my favorite thing to do, but I want everybody to, let's try that again. What form are we writing these rules in? Component form. Okay. For addition, if I wanted to take U plus V, and I know that here's U1 and V1, I'm going to first say that our answer is R, and we can sneak this in. This is for the resultant, which is the resulting vector. So it makes sense that we would use that word, resultant. Weird. Okay. How does a rule work based on what we did above? We have a new vector. How do I get the new X coordinate? You say Adam. Add what?
X's and then add the Y.
And what are the X's here? Based on the vectors we're working with. U1 plus V1, comma, U2 plus V2. You just add the X's and the Y's. If I had 4 vectors to add up, would the same still apply? We would just add 4 things instead. Okay. Feel okay with that?
Yes.
Okay. Sweet. So we have addition. Nothing crazy. The only other operation that we're going to see, at least for today, is going to be what we call scalar multiplication. And I'm going to I lied, I'm not going to shorthand, but you guys can and should. Scalar multiplication. Okay. When we do this, when you see the word scalar, it's kind of ugly. What word does it look like? What does it mean to scale something? So bigger or smaller by a certain amount. What was yours? Oh, that's interesting. Not where my mind goes, but yes, I agree with you. I like, for the mathy version, I like the other one. Could we have a vector in front of us and make it 3 times longer? I'm scaling it up by a factor of 3. What if I make it half as long? What if I make it -1 times as long? What do you think that'll do with it? And that's a weird idea. Ooh, I want you to do that again once everybody's looking at you. And I know you don't love that, so I'm sorry. I will do it. Here I am, and ask me the same question. What did it do? I didn't crack. I didn't. It wasn't me.
That's gonna be so bad.
It wasn't even my thumb.
Like you turned it.
Okay, but it just changes direction. If we have a negative vector, all it does is go in the negative direction. Okay, so check it out. If we had something like this, and we're just going to write it out. If we had k, which is just some real number, times a vector, we'll call it u. And we wanted to expand this out, and this is like the definition of how this works. This would just be k times this thing, u1, u2. All I've done is I've substituted vector u. Anybody have a gut feeling on what should happen here? Your gut will be right, I assure you. Yeah, let's just distribute. KU1 and KU2. And look at that, we're done. We can scale them up. If it's negative, the direction's just opposite. And now, just a really quick thing, you guys do not need to sketch this, but let's say that, because I have a coordinate plane here, let's say this is a vector, nope. Let's say that this is a vector in standard position. We'll call it just, I don't know, W for fun. If I wanted to draw negative W, it still is here. Which way should it go, though? If this is W, what direction would you say this goes? Up and to the right? So what's the opposite of up and to the right? So if this went right 1 and up 4, what's the exact opposite of right 1, up 4? Left 1? Do you guys agree that these two vectors are the exact same length or magnitude, but they're going the exact opposite direction? If I added them up, tip to tail, where would I wind up? The origin. And just to convince you of that, in case it's hard to see, this is going to be a weird one. I have no idea where that put it down, so we're going to try that again.
Whose graduation task is that?
What year is it?
I can't see.
2018 is the last class that I was the graduating advisor. Hey, when I add them, does it indeed take me back to 0, 0? Yeah, that would make sense. U and negative U undo themselves. Yeah, okay. Be prepared to have to sketch them. We're not going super crazy with it, though, here. Okay, should we take a quick brain break?
Yes.
Okay.
Oh, the number thing?
Yep. It's like Math Wordle, 100%. Cool.
There is Math Wordle.
Is it called Pips?
No.
Oh, okay.
It's
Fair. All right. For these, I don't really need us to do a ton of examples with it, but I need you to prove to me that you can do it. I need to put this in the right spot. Do you want examples on the boards, or do you want examples in your notes?
Notes.
Okay. You have 1 or 2 vectors to add real quick is all. And I'm going to move this up here, just so I can get them all straightened out. And then I'm going to tweak the problem just a little bit. For the following, I want you to find the resultant. And we'll go ahead and put this as an example. So I'm going to make this, what's the standard that we're going to use for the resultant? So we are going to say find for the following vector R, which will make sure that it's stated how to get there. And beyond that, I also want you to find whatever this means. Do not shout out what this means. I want you to look and make sure that each group independently knows the notation to what it is I'm writing. So I want you to find R and R with 2 bars around it. And here we go on A, and let's define a couple of vectors here. Let's define 3. Lay, what do you want vector U to be? 4, 5? Davian, what do you want vector V to be? -8, 10, I heard. Okay. Interesting. Cool. Well, I kind of like this idea. And let's go W for one extra one. And we show what's W? Nope. Why would I use brackets? Sorry, 6-5 is fine. I just used the wrong notation. My bad. All right. On A, let's try it out. I want you to do, let's say 2U plus V minus W. And that is the resultant. Cool. That's a good question that I would encourage you to ask your notebook or your neighbors. It is not absolute value.
Remember doing it.
Yep, it's in your notes, as long as it's in somebody's notes. All right, have fun. Talk it out. I want to hear you guys talking, even though you're not up at the boards. Act like you are. Talk with one another. You all got this. I assure you.
I don't know how to do this.
What's up? And we'll come back to this. It will make sense because we'll see it. You guys, we did not formally define the magnitude. You're right. We don't have a formula for it, but we'll get it, and we're gonna see where it shows up. Not yet. You will. I mean, you're probably using the right one if you're trying. If you think you are. Okay. Decision time to how much I showed. Do I really need to write all three of these adding up?
No.
What's 8 plus negative 8
0.
plus negative 6?
Negative 6.
So negative 6. What's 10 plus 10
20.
minus 5?
15.
Okay, this is what I get as a resultant. Do you guys agree with that?
Yes.
Red, what's up?
I did 15 squared in my head and I hit 0.
Okay, so let's make sense of this really quick. Even though there's a grid, can I just pretend like it's to scale and not actually count? Okay, so I just want us to like really think about this for just a second, and this is gonna be pink for thing, okay? If I put this as my origin, right here, negative 6 and 15, so I should have put it down here maybe. So there's my origin all the way down here. It says R should go 6 left and how many up or down? So we'll say each is 3, 6 left and 15 up. So here's the point 6 comma 15. And from the origin, and I don't have a straight edge. Oh, yeah, pretty good. Do you guys agree that that's what the resultant vector looks like? Okay, I did not give you a direct formula for this, I don't think. But if I forget about everything else, because I didn't sketch all the other vectors here, right? This is a coordinate plane, and have we ever found distances on the coordinate plane? You could. First thing I need you guys to be able to tell me is when I write this, R like this, what am I asking for? The magnitude of R. Now, here's what I want us to think about. If I were to drop down a vertical right here and a horizontal, because I'm working in components from component form, what's this length? So negative 6, and I know that the negative is odd, and this is 15. How on earth could I get the magnitude of R? 225 plus 36 is what? 261?
Yes, it is.
Yeah, the root 216, which is 3.
Oh, using distance
29.
formula?
Oh, I use distance formula.
So
Which also works.
I love that I heard somebody say I use distance formula, and then I heard
thought it
somebody
was
else say that also works. I want to tie them together. Are they different? Or is the Pythagorean theorem just always going to be the distance formula from the origin? They're the same formula. If you don't remember both, that's okay. Any distance that you ever need to find, you can make a right triangle like this and use Pythagorean theorem. Distance formula is convenient, but you don't need it. We have Pythagorean theorem. Okay. Super hard. No, good. Now, we are going to use the rest of the time to get a little bit of head start on the stuff. Last question, and this is going to front load for tomorrow. What makes the unit circle different than other circles? What's the unit part of it? Or unit square? Like, we haven't talked a whole lot about unit squares, but they do exist. A unit circle, there's some really nice value about it. The center's at the origin, which is really convenient. But what makes it really, a radius of 1? What do you think the length of the unit square could be? Could it be 1 by 1, and that's now just the unit square? If we make a unit trapezoid where we have, unit trapezoid would be weird, that one doesn't work, I'm sorry. But the fact that 1 is there. If I had a vector, and I'm not gonna keep going, so I'm just gonna start the next part of this lesson if I keep talking. So you guys get some practice with this. All right. I'm not writing as much as I have in past years. Does it feel okay?
Yeah.
Okay. I'm not going to. Did we have homework?
No.
Okay, so we'll just go ahead and put it up here for tonight. We're gonna call this homework.
Was it the date you just wrote?
It is 4-4, and this is lesson 6.3.
You know it's 6, right?
No, I did not know that.
Okay.
Thank you. Okay, lesson 6.3.2, and this one's gonna be weird because I'm gonna call this homework 6.3.1, even though there was only one part to it so far. And let's see, nobody has a pre-calc book open. Well, I'm gonna add a couple more to these just so you know. 25 through 33 odd. I guess I can give you the page, 427. 25 through 33 odd. 39 and 41. And then I don't know what this is about, but I have a note that says no sketch, number 33. So apparently you're not supposed to sketch 33. Indeed. And I won't add problems today. Tomorrow, you guys will be here still, right? You guys aren't testing or nothing.
No.
Okay. Cool. AK Star and PSAT happens tomorrow. So, yeah. Cool. At some point, we'll have to have you guys bring in computers. If we plan for Friday, bring your computers. Can we all agree that we'll have them charged and turned on before this class? We all need to log on to College Board and accept something. Cool.
Mine doesn't charge or turn on.
Bring a charge. Well, like it doesn't turn on.
I'll try.
I'm okay with it. I don't mind if it's your personal. I'm cool with it. Yes. So that's what for. I'm always weird with days and numbers. Are you okay? You can step out if you need to. I don't know. You look like you're not happy
Oh,
or you're
no.
uncomfortable or something. Okay. You're good to step out if you need to, just so you know. I never know if 4 days from now is going to be the 10th or the 11th because I never know where to start counting. Like, I don't know why my brain just can't do it. Cool.
No.